Hello friends, hope you are all doing well. And so last day I had discussed PoSET, and today I am going to show you two very simple examples on PoSET. So let me start with the first one. Let Z be set of all integers. Define row in such a way that A row B hold if B can be expressed as B is equal to A to the power R for some positive integer R. For example, 2 row 8. A is equals to A to the power 1. So A row A. So the reflexive property here satisfied, cos A to the power 1 is equal to A. So the first condition to be a PoSET, and that is reflexive, so that has been satisfied. And now the second property to be a PoSET, that is A row B and B row A, imply B is equal to A to the power R1 and A is equals to B to the power R2, where R1, R2 are positive integers. This implies B to the power 1 by R1 is equals to B to the power R2. Since R1, R2 are positive integers, so R1 is equal to 1 and R2 is equal to 1. So A row B and B row A is B is equal to A. So the antisymmetric property satisfied. And now we will check the third condition of a PoSET, and that is transitive. So A row B and B row C. So we will write B as A to the power R and C is equal to B to the power S. So, and R, S are positive integers. So A to the power R will be is equal to C to the power 1 by S, and C is equal to A RS, A to the power R into S. So this is A row C. So first RS is a positive integer. Thus row is a partially ordered and Z row is a PoSET. This satisfied the transitive condition of a PoSET. So thus Z row is a PoSET. Hence 2 precedes 8 and 8 succeeds 2. And now the next example on PoSET. Let Z be set of all integers and divisible be a relation defined in such a way that A by B means B divisible by A. Example 5 by 60. Then we see A by A for all A in Z. 3 by minus 3 and minus 3 by 3. But 3 is not equals to minus 3. So the relation divisible is not antisymmetric. Hence Z and divisible is not a PoSET.